All right, so today's lesson is about classes and methods, and classes especially and their accompanying methods are a very important concept in programming. You'll see this concept a lot, no matter what language you're using, whether it's Java, Python, C++. It's just a very important concept, and it's really important to understand it really well. But unfortunately, it's also a very tricky concept to understand at first. So if you have any questions at any point throughout the lesson, just tell either me or Renee, and then we can answer it immediately so you don't get confused. Oh, wait, whoops. Okay, actually, it's fine. All right, so let's answer the basic question. What are classes? Classes, just like functions, are another way of packaging useful information together. So in a function, we have the package is essentially the name of the function, and the content of the package is essentially the code of the function. And then quick review, instead of having to write out the code of the function every single time we want to use that code, we can put that code in a function, and then we can just call the function every time we want to use that code. All right, and then classes are sort of similar to that. So it's kind of a little connection piece here. And then before, remember how we imported things used for user input, like import java.util.scanner? When we were doing that, we were actually importing packages and also specific pre-written classes that were included with Java. All right, and packages are basically just, they're just code packages, and then classes is what we need to use to do user input. But of course, we can import other classes to do different things. All right, so classes are just sort of like a blueprint for what we want code to be like. I'm just gonna check something real quick. All right, like blueprints for what we want the code to be like, and I'll just explain this. All right, so if you have a class, let's say we want to have a class to be dog. All right, and instead of saying code, let's just say object. So let's say we have a class called dog, class dog. Actually, wait, what the heck am I doing? All right, sorry, pretend I didn't do that. No. So classes are just like blueprints for what we want code to be like. I'll give you an example in the next slide. And when you create an object of that class, it will allow you to use that code. So we're going to teach you how to do all this stuff in the lesson today. So, fun little fact, but strings, which are a type of data type, are also a type of object. And they're not a primitive data type such as int and double. And you can see this because when you type in, when you go to JDoodle and you type in int or double or float or boolean or short or whatever data type, it's going to turn purple because it's a keyword in Java. But strings, if you type in string, you won't get that because strings are not a keyword. They're a type of object. All right. And object, we'll talk about this later, which is another pre-made class, is a superclass of a class. So there are a bunch of pre-made classes in Java, but some of them are like, when you install Java, when you like use Doodle or something, it's already built in there. So you don't even need to like import. You don't even need to import it because it's already there. You can just reference it. And object is kind of like classes. It's just built in. And you can create as many classes as you want. And then classes, what they do is they contain attributes, which the programming word for that is instance variables. It contains methods or functions and constructors. So a good example of this is, let's say we want to create a dog class. This is what I was talking about earlier. All right. So let's say we want to have a class called dog. All right. And so what are some attributes, or in programming, instance variables? Let's just look at attributes. So what are some attributes of a dog, right? It has a tail, it has an eyes, and the eyes have a specific color, and it has ears, right? Tail, eyes, and ear. All right. So those would be like instance variables. So you would have a class dog, and then you have three attributes: eye, tail, and ear. And obviously, not every single dog in the world has the exact same eye color, the exact same kind of tail, or the exact same shape of ear. So this is why we have classes, just like a blueprint, like we said before. So when you create an object of the class, we're essentially creating we're creating a dog, right? And then when we create that dog, we specify what these attributes and what these instance variables are. So let's say I want to create a dog with brown eyes, a long tail, and a round ear. All right, that would be in one dog object. Then we could have another dog object, and let's say the eye color is blue. The tail is very short, and the ears are more pointed. All right, so that's sort of how classes are sort of like a blueprint for real world objects. And in addition to attributes or instance variables, classes also have methods. And methods are basically like functions or things that the object can do. All right, so let's just go back to our dog class. We've got our attributes worked out. And now what are some things a dog can do? It can play fetch, it can bark, and it can bark. So we could have like a method inside of the class dog called run, and it could have some code for how it's running. And then we could have a method for fetch, and we have some code for that as well. So that's sort of how like classes work. You have attributes, which are properties of or attribute properties or characteristics of something. You have methods, that's what that something can do. And then you have constructors. So we'll explain constructors in I think in 2 slides. But for now you just need to know what attributes and methods are. All right, so here's an example of a class. So all right, so here's an example of a class. This is just the whole program, and we have a bunch of comments on the side that tell you, okay, if that explain what every single one of these things does. Hold on a second. I need to be able to see the comments. All right. So, and of course, if you got, we're going to post a link to the lesson slides in the links page. So if you would see something like this, you can just go to the class slide and you can look at this yourself in case you need a review. And maybe the lesson slides aren't super good for you and you want to see like a real world or how it actually works with this lesson slides information. And this would be a good way to do it. So we're going to go over the attributes and the methods of the class. So here, instead of having a class dog, we have a class called vehicle. This is just a quick little bit of information. When you name a class, the first letter of every word is capitalized, including the first word. So here our class is named vehicle. So we just have V is capitalized. Well, let's say we wanted our class to be called, I don't know, textbook. It would be textbook for school. All right. So it's pretty simple. We just capitalize the first letter of every word. So T would be capitalized. I'm going to treat textbooks as one word. F is going to be capitalized, and S is going to be capitalized. So this would be the name of the class. And then to say that, oh, this is actually a class, we just have to write class. By the way, this is lowercase. All right, so those are just naming conventions for classes. But let's take a look at the code now. All right, so we create a class, and its name is vehicle. And then these are the attributes or instance variables of the class. All right, so we will explain what this private word means, but for now, every time you create instance variables, just for private, all right? It's just best practice. It's just good to do. And these are the instance variables, all right? So of the class vehicle, we're going to say, okay, so this vehicle has 3 attributes. It's going to have an attribute called gas, how much gas it has left, miles, how much miles it has traveled, its mileage, and then we're going to have its status, or just its color, basically. Yeah, just its color. All right. So notice how when we create these variables, we don't automatically say what they are. So if it was just a normal variable, we would do something like this, 5. But here, we don't set what these are. That's what the constructor's for. All right. And instead, we just say, we'll just do this and a semicolon. So let's say, okay, so we're going to create, oh my, I'm such an idiot. Okay, so we're just going to create an integer variable, a static integer variable called A, but we're not going to say what it is. Not yet, anyways. So like I said, these are just the variables of the attributes or instance variables of a class. And then this is the constructor. Talk about this in a second, but this is the method. All right, so what can this field do? We already know it has a gas attribute, it has miles attribute, and has a status attribute. But what can it do? And we're going to create a method here called print info. And what it's going to do is it's going to print out gas, it's going to print out miles, and it's going to print out status. All right. So this is just like a regular method, but the only difference, this is just like a static method, but the only difference is that there's no static and it's used differently. All right. So this is the constructor part. I'm just gonna. All right. So this is the constructor and it has parameters, but notice how unlike static methods or class methods, there is no return type, but there is only an access modifier and a constructor. And the parameters that this constructor has or is going to take in are G, M, and status. So basically this is saying that, okay, so when you create an object of the vehicle class, you're going to have to pass in an integer. You're going to have to pass in another integer, and you have to pass in a string in that exact order. All right, so let's say I want to pass in 5, 5, and yellow, right? This would work, but like before, this would be an illegal argument exception, like we learned before in static methods, because Java is expecting you to pass in an integer, but you passed in a string, so it'll give you an error. All right, so the constructor takes in these 3 parameters, and then it's going to set the attributes or instance variables of the class to whatever value, whatever these parameters are. All right, so here we're going to set gas equal to the parameter G. All right, just like this. And we're going to pass in, we're going to set the instance variable miles or the property miles to the parameter M. And now we're going to set, this status? All right, that's kind of weird, right? You guys probably haven't seen this before. That was so cheesy. All right, anyways, but Java is actually, since we have an instance variable called status and we have a parameter called status, when you say, let's pretend this wasn't there. When you say status equals status, Java has like, hey, which status equals which status, right? It doesn't know which one you're referring to because they have the same name. So to fix that, we have to use, oh no, it's not commented anymore. Okay, well, I didn't expect this, but okay, I'll fix it in a sec. All right, so to prevent Java from getting confused, we have to use the this keyword. And it just says that whatever comes after the this, we want that to refer to our instance variables. All right. So it's saying that, okay, so we're going to set the instance variable status is equal to status. And since you already know what this status is, it's the instance variable from up here, then we will automatically know what this one is. It's just a parameter. So that's just how Java implements these naming conventions. So I think if I do this, I resolve it, I scan it again, I comment, I paste it again. Okay. All right. All right. Hopefully that works. Okay, okay, it looks kind of weird, but hopefully you guys can still get it. But that's just how this keyword works for the instructor. And yeah, that's about it. So let's provide an example. All right, let's say, let's not go here yet. Let's just say we passed in variables 5, 3, and p into this constructor. All right. So just like with functions, the first parameter corresponds to the first value that's passed in. The second parameter corresponds to the second value that's passed in, and so on. So if you create an object passing in these three parameters, g would equal to 5, m would equal to 3, and then status would equal to happy. All right, actually, this is a bad word. I'll just say no, just like before. All right, so we're gonna say the instance variable. So for this specific vehicle, where we pass in these three parameters, we want the gas property to equal 5. And g is the first parameter in the constructor, so it corresponds to the first value. So 5 is g, and then we put g here, so gas equals to 5. So I'll just say 5. And then we repeat the similar process here. We have the second parameter corresponds to the second value passed in. So we're going to say miles is equal to 3. And then for the final one, yellow, let's do this if you guys want to read it. And then yellow, this dot status equals status. Remember, this refers to the instance variables inside of your class. So we'll refer to this. And then this status refers to the parameter. All right, so then this would equal to yellow. And that's it. That's basically how the constructor works. And now, every time, I'm just gonna take a look at this. All right, here, this is a good one. All right, so the instance variables names that we created above, int, gas, miles, and the string variable status are what we would be using inside of the class. Remember, the class extends from here all the way down to here. And all right, so the instance variables are what you would be using inside of a class if you needed to use it. So review, we use the constructor to set what all of the instance variables are. And now every time we need to refer or use one of these properties, we can just use the name. And every time you create an object of this class, it can be different depending on what you pass in. All right, so that's basically how the constructors work. Does anyone have any questions before we go back? Where's the chat, teacher? All right. I don't think there's any questions at the moment. I'm gonna go back to the slides now. All right, so that's just an example of a class. Class was vehicle, and now we're just gonna give the information. So this will be covered just now, but we're just gonna go over it again since you guys can sort of visualize how it worked in the example. We're just gonna do a little bit more information to help you guys remember it better. So constructor is where the class sets all of its instance variables with parameters that are passed in. All right. So before, when we passed in 5, all right, when we passed in 5, 3, and yellow, those are the parameters, and we're going to set those to the instance variables gas, miles, and status. And if a class does not have a constructor, then by default, the constructor has no parameters and doesn't do anything or set anything. All right. So it's not required, but if you wanted to do something like we did before, like a blueprint, you wanted to have attributes and stuff like that, then you probably would want to use a constructor. All right. So that's how a constructor is. If you guys want to go back to the example slides, you can always go to this link and look in the doc. But let's go to methods and variables now. So the methods inside of a class are just like static methods, which is the methods that we used before, but the only two differences is that they don't have the static keyword in their creation. So static method would be public, static, return type, name. But for this, it would just be public, no static, just a return type and the name. And they're called or used differently. And besides that, they're the exact same thing as static methods and can do the exact same things. All right. And so, okay, so instance variables are originally not set when you first create them. Remember the attributes, the private, int, gas, mile, and stuff like that. Remember how we didn't set them. We didn't say what values all of them equal to. We just say that we just created them. We just said that they exist. And then usually you're going to set these instance variables inside of the constructor, just like we did before. All right. So I'm going to show you how to create an object and how to use the instance methods from the vehicle class. So we're going to go back to here. Now we just reviewed how all of the class works, how class vehicle works. Now we're going to go back to the main method here, and we're going to see the creation of it. All right. So C is the name of whatever object you're creating, and vehicle is the class name. All right. C, class vehicle. So basically what this is saying is that we're going to, all right, actually first for classes, if you want to create an object of that, you have to do it in the main method, and you have to create an object if you want to use any of its instance methods. All right, that's very important. So let's say we didn't have this, then it'd be impossible, it'd literally be impossible for it to use public void print info, because the way you use it is that you create an object and then you call that method using the object. All right, so let's go back to here. All right, so we're gonna, vehicle is a class name just like before. So what this is saying is that, all right, so we want to create a vehicle object and its name is going to be C. And then new, this is a keyword for creating an object of a class. We're going to say we want to create a new object of the vehicle class, and the parameter that we want to pass into the class vehicles constructor is 500, 1000, and green. And remember, these three values get passed to the three parameters inside of the constructor. You see how everything is connected a little bit? And then C is just the name of the object that we just created here. And then print info is this instance method. So in order to use this instance method, you use the variable name or the object name, and you need to call one of its methods, right? And then it will execute essentially. So print info is a method, and we use the object, and then we use the little the dot character, and then we have the method name. All right, so this is how we use the vehicle object C to use its instance method print info. And then in this case, print info actually uses the three instance variables, gas, miles, and status that we used before. All right, so when it uses print info, and then so when it calls print info, gas, miles, and status are going to be set to whatever parameters you passed in when you created the object. In this case, it would be 500, 1000, and green. You guys see that? All right, I'll just say it again. So when I say print info, okay, so we're going to print out gas, we're going to print out miles, and then we're going to print out status. But since the instance variables gas, miles, and status are set to the parameters that are passed into the constructor, gas, mass, and status depends on what parameters you passed into the constructor when you created the object in the first place. All right. So since we present 500, 1000 in green in that order, G is going to equal to 500, M is going to equal to 1000, and then the parameter status is going to equal to green. And then we set all of those values to the actual instance variables themselves. So now public void print info knows what gas, miles, and status are. So after all of that, the output should be 500, whatever gas is, space, miles, which is 1000, and then its status, which is green. All right. That might have been a lot of information. So please don't be afraid if you have any questions or clarifications. Other than that, that's basically the end of this lesson.
All right, something somebody's entered in the chat that I think I can explain out loud a bit is it possible to make the parameters into user inputs? I'm not too certain what you exactly mean by that, but if you're talking about like actually having a scanner to like actively ask the user for user input, and so therefore you don't have to enter a specific like parameter in, then yes, you are able to do that. You can specifically, I think so. I don't think I've ever really tried it before, but I'm pretty sure you can do that. And so essentially you would just put in the parentheses for when you're creating the object that you would just say like input.next int or something like that. Or something else you can do is essentially ask the user ahead of time what they want to enter. So you can set, okay, if you're asking for an integer, you can say int a equals input.next int, and that would be the user input value, and then you can put that variable into the constructor when you're making the object. So yes, you are able to use user input values. Okay, that was like a really long answer to like a pretty simple question. Okay, but yeah. And you can see later that Java is very, you can do a lot of different things with it, and you just have to get used to like the way we look at things. And it looks weird sometimes, but it's all a matter of getting adjusted to that. And Leo's coding something right now for that.
All right, so this is just an example. All right, so you create an input.utility scanner. I'm not sure if we still need this one, but I always include it because it looks cool. Yeah, so we're gonna create a class called example. I'm just gonna go over this real quick. We're gonna have two instance variables that are both integer called gas and miles. And as you can see, when we pass in parameters to the constructor, when you create an object, instead of saying like, oh, this is just gonna be 5 and this is gonna be 200, you can just say, just replace it with whatever the user inputs, which would just be input.next int. And now when you set gas, the parameter gas, and when you set the parameter miles to the private, not the instance variables, gas and miles, it'll be whatever the user inputted and not what you inputted directly. All right. So this is a quick example. Hopefully this answers your question, but the answer is yes. This is Renee's thick boy class. There's a lot of fancy stuff going on. We can do it, all right? So before we go through all of this, let's first discover what addition, division, multiplication, and subtraction are, and what the calculator class actually has inside of it. So there are about 500,000 comments on the side. So if you guys just want to read along, just like before, you could just like follow along with us, read the comments, listen to me talk about stuff, and then yeah. All right, so hopefully everyone remembers this by now, but these are the instance variables of the class. And usually, just like here, they're not set to any values in particular yet. that job is for the constructor to do, right? So the two variables, the two integer instance variables that we're creating are first and second. And remember, I'm just gonna click enter a few times. 1, 2, 3, 4. All right, so remember how the name of the class and its constructor is exactly the same. All right, like class calculator, public calculator, exactly the same. All right. So the constructor is going to take in two integer parameters, a parameter called f and a parameter called s. And these values are set to whatever the user passes in, when it creates the object. And then we're going to use these parameters and we're going to set the instance variables to whatever the user passed in. All right. So let's just pretend, just for an example, I want to pass in 10 and 4 when I create this object. I'm just going to see if there's any way I can. Never mind. All right. So then first will be set equal to f. And since f is the first parameter, it corresponds to the first value passed in. So that means first is going to equal to 10. And then s is going to equal to 4. All right, so we got that worked out. And now these are all the operations or the operators that the calculator can do. It's just gonna be the first 4: addition, subtraction, multiplication, and division. So addition, pretty simple. And I'm going to start referring to the class methods as instance methods. All right, so, new terminology, I guess. So we're going to create an instance method called addition, and it's going to take in no parameters because the parentheses are blank, and it's going to return an integer. All right. And please, actually not please, but notice how instance methods and static methods are virtually identical. The only difference is that there's no static word here. And all right, and they're both used differently. All right, so if you want to use an instance method, you have to create an object of the class in which it is in. So I will need to create a calculator object, and then I'll need to call this method on that object that I create. All right, so this is pretty simple. First is equal to 10, second is equal to 4. We're going to return their sum. So if we did, let's say we called addition and we passed in 10 and 4 as the values, the output would be, not the output, what's going to be returned is 14. All right, and now here's a subtraction. All right, this is a little more thick. This is most of this, actually, this is just the error message that we want to output, but this is like code stuff, I guess. All right, so unlike the addition method, we actually want to have a parameter. And yes, since static methods are identical to instance methods, except for the two differences, that means instance method can also take in parameters. All right, so this instance method is called subtraction. Its return type is going to be an integer. And then we're going to take in, it's going to take in a parameter, an integer parameter called decision. All right, I want to see what this decision means in a second. All right, so, okay. All right, so let's first focus on this if statement here. All right, so if decision does not equal to 1, and actually, all right, let's go over this first. So, and these are called the and operator, all right? And, okay, that sounded weird, but, and it returns true if the two expressions on either side of it also return true. All right, so if decision does not equal to 1, let's say that was true, but decision 1 equals to 0, which will make this false, then unfortunately, since this is true and this is false, both of them are like, they're not both true. So the AND operator would return this whole thing as false. All right. But let's say the number was 2. All right. 2 is not equal to 1. I mean, let's say decision was 2. Sorry. Decision is 2 is not equal to 1 and 2 is not equal to 0. So this method would execute. All right. So let's just pretend I'm just gonna write something. All right, let's just say decision equals to 2. That means this whole thing is true now. All right. And then we're going to go into this whole nasty little thing. And then remember what exceptions are? They're very similar to errors. But let's say we want to throw an exception manually. Like usually we want to do this, but for this purpose, we actually find a use for it. I'm just going to say throw the keyword to say, okay, we're going to throw an exception. New, the keyword to create an object. And this is the exception that we want to throw. All right. So this could be anything. Let's say we wanted to throw a negative array size, exception, or a negative array index, or array index out of bounds, whatever, right? It could be anything. Then you have any exception here. But since decision is going to be passed in as an argument, we're probably going to say it's an illegal argument exception if it's not 1 or 0. So we're going to throw our very own error, and then we're going to have a pair of parentheses that begin here and end here. And whatever's between that is just our error message that we want to print out when the error happens. All right. So the error message is you need to enter either a 0 for the second number you entered to be subtracted from the first number, or you need to enter 1 for the first variable you entered to be subtracted from the second variable you entered. So here we see the use of having a decision parameter. So let's say if decision equals to 1, then you want the first variable to be subtracted from the second variable, just like so. But let's say we inputted 0 as our decision, then we're going to have the second number we entered be subtracted from the first number we entered. All right, so that's how the subtraction method works. And now we enter here. Now this is the logic for, this is the logic that the error message told us it would do, essentially. So if the decision variable is equal to 0, right here, then you want the second number to be subtracted from the first. And whatever the value is, we're going to return that because this is our final result, essentially. And then, okay, well, let's say decision was equal to 1. All right. Then we'd have return second minus first. Right here, we want the first variable we entered to be subtracted from the second variable we entered. And let's say that user did not input 0 and it did not input 1. We already have a little check here in place to throw an exception and then give them the reason why the exception occurred. But just in case none of these conditions evaluate to true. And that shouldn't occur because we already have a check in place here. But just in case, we're going to need to fulfill the requirement of having a return type here. So I'm just going to leave it there. This is just a, actually I won't add it. All right. So does everybody get how that works? All right. Oh yeah, and in case you guys are wondering why, in case you guys are wondering why we don't have this decision if statement here for addition or multiplication for that matter, it's because I think it was like the commutative property, something like that. It says that for addition and multiplication, it doesn't matter what order you perform the operation in. So first plus second is equal to second plus first. All right. And for multiplication, first times second is also equal to second times first. But that's not the case with subtraction. So let's say first equals to 10 and second equals to 4. Then 10 minus 4 is not equal to 4 minus 10. So that's why we have the decision there. But 10 times 4 equals 4 times 10. And 10 plus 4 equals 4 plus 10. All right, that's basically how it works. Okay, there you go. And it's pretty simple, but the only unique thing that we probably haven't seen very often is that the return type is going to be a long. And remember, longs are basically integers, except that the range of numbers that it can be is much bigger. So the range of an integer is from like 2.7 something billion to negative 2.7 billion. And then for longs, it's like much bigger than that, right? So this is just in case our user would enter like some crazy high number for first and second. So we're just going to return whatever first is times second. And remember, all the way back from before, first, in this case, equals to 10. And second equal to 4. Right? Because we have the instance variables. And then we're going to set first equal to f. F corresponds to 10. The instance variable second corresponds to the parameter s, which is 4. All right. And now that's how multiplication works. Now the last one is division. And just like subtraction, 10 divided by 4 is not equal to 4 divided by 10. Right? Actually, I'm going to make it double division, so it's what we're used to. Right? So that's why we need to have the decision thing. So we just do that, and we can look at the code. All right. So the return type for the method called division is going to be a double, a decimal, because obviously, you know, division can result in a decimal. And we're going to have the same, we're going to take in an integer parameter called decision, just like before, all right? So this and this are basically...
In the sake of time, go faster.
All right, I'll go faster. All right, so basically this is the exact same thing as this. All right, and then we have the and operator. Just says that if these are both true, then this is also true. So if it was 2, this would equal to false. If it was 0 or 1, it would equal to true. And then if decision equals to 0, then we have the first number divided by the second variable. We're going to do first divided by second, assuming that they're doubles. And then we're going to cast that into a double, because obviously it's not always going to be an integer. And then we're going to return that. Else if decision was equal to 1, then we're going to return second divided by first, as you can see here in the error message, and we're going to return that. But before we return it, we're going to cast that quotient into a double. And just like in the subtraction method, we're going to have this safety net return 0.0 statement in case none of this works, to fulfill the requirement that this method has a return type.
We don't have to do that, but
so that's it, guys.
Do it as an exercise later, and yeah, just try it out, because the top part is essentially the same thing. It's just using like expanding on how to like use these methods. Yeah, it's just review it on your own time. I think like as you review it a bit more, as you try to code more, I think it makes more sense later. So try it out yourself and kind of determine the output of things.